To understand why memory management is such an issue, we need to understand something about how objects are actually created. Now, if we have an area of memory that we're going to be using to create our objects, there's actually a two-step process that happens for every object that we create: allocation and initialization. Now, with the examples we've seen so far, we used a line of code like this. We were using the new operator, and what it was doing was actually doing two things: both allocating and initializing an area of memory. Well, what's the difference? Well, allocation is the idea that it's going to go to that area of memory and claim an amount of space big enough to hold this object. So what it's going to do, in essence, is look at all the instance variables that are defined in this object's class definition and claim the amount of space that that's going to take up in memory. The second part of this, the initialization, is saying now it's going to go through all those variables and initialize them. Now, this can start off being very simple, that it's just initializing things to zeros. But as you create more complex objects, it can actually do very complex initialization. So if this one line of code is actually doing two things, why are we actually talking about this? Well, because you'll more commonly see this defined a different way. That when you create an object, you're going to do the allocation and the initialization explicitly. The way we do that is, well, I'll show you a version where we write two lines of code. Instead of using the new operator, we'd call the alloc method on the dog class. And that will go out and claim an area of memory. But it's not really usable right now. What we need to do is also do the initialization and kind of pave over that area of memory and make it ours. So in this case, the way I'm doing it is by doing two lines of code. I define this new object called Fido. It's a pointer to an instance of a dog class. And I call the alloc method to allocate that area of memory. Then I call the init method to initialize that. This is the more common way of doing things. However, we don't usually write it on two lines because that's just a little clunky. Instead, what you're going to see much more commonly is a line of code that nests both the alloc and the init call together. So the dog space alloc init square brackets is nested inside the init call. And this is the most common way you're going to see objects being created in Objective-C. A lot of other languages like to use the word new. Objective-C, it's much better to be explicit that we have two steps here: allocation and initialization. This is one of those ways where we are creating the objects. We are now responsible for it. If we use alloc and init or new, think about it this way, that they're the same thing, that we own these objects. We must later release them ourselves. So the format is very, very common. It's going to be the class name, the name of your object, equals, and then a nested call to your class name alloc, and then the init call. You'll see this all over the place. Person Fred equals person alloc init. Customer Acme Corp equals customer alloc init. And even all the built-in objects inside Cocoa Touch, such as ns auto release pool pool equals ns auto release pool alloc init. If this looks vaguely familiar, that's because this is one of the lines of code that's very commonly created when we make a project in Xcode. This is a demonstration piece of code right from a basic project definition, and we notice that line 4 here has ns auto release pool asterisk pool equals ns auto release pool alloc init. What this line of code is doing is creating a pointer to an ns auto release pool object. That pointer is called pool, and it's doing both the allocation and the initialization of that object. So it's very, very common that you're going to see that all over the place as you create your objects, both the alloc and the init nested inside the square brackets. So let's say you're using one of the built-in classes in Cocoa Touch and you're just using the new operator to create it. And you might think, I don't quite see the benefit of instead changing it to the alloc and init. So why would we use the more complex-looking alloc and init over new? Well, there's a couple of reasons. One, it's way more common to see alloc and init for years and years of code, so you want to get used to looking at this. The other reason, more specifically, is that the init calls can actually be specialized. We can have multiple different types of initialization. So say if you're working with a string, you can have the alloc and init combined so that the initialization also sets the value of the string. And you have another example where you can have an alloc, and then I've put this on the next line here, and I've got a more specialized initialization called initialization with format, or init with format, that can take a format specifier, and I can start to put in lots of placeholders for a different kind of string, creating a message. So having more specialized versions of init is very, very useful, and you'll see this a lot. So what I'm going to do as an example is just in this basic project, if I start typing nsstring, my string equals, and I'm having the 2 square brackets because I'm going to nest the nsstring alloc call, and then I'm going to type init, and notice how it's popping up different options for me for initialization methods. In fact, if I type the word init and I want to see all my different options here, I can just hit the escape key, and what's going to happen is I can see I seem to have lots of different initialization methods to call. Init with bytes, init with coder, init with contents of file, init with contents of URL. This is where we're seeing some of these method names with the colons in between them are obviously taking multiple parameters to them. So there's a whole bunch of different init methods. We do, of course, have the most basic init, but that's not really going to do anything. The rest of these initialization methods allow us to do something with this variable as soon as we've created it. So that's the reason that we typically use alloc and init rather than just using new.